Now we will see this module called Input Creator. In Input Creator, you have uh, this tabs here. Then here you have the input and script editor. This is editable. So, and here you have a geometry tab, and here you have a visualization window. For example, this is a geometry tab in which you can paste your XYZ coordinates, or you can load your uh, coordinates from here as well. So when you click on visualization, this is a default visualization, that is AutoChemy Viewer. AutoChemy Viewer comes with it. So if you click on these two atoms, it will show you the bond length. If you click on three, it will show you bond angle. Okay, so but you're not restricted to this visualization only. So you have a multiple choice. For example, JMOL, Chemcraft, Avogadro, Gosby, whatever you are comfortable. You can just install it and give it the path. So how you can give the path? You can go to this paths and manage software path and add the software. Just put the name and give it the location and just save it, and you're ready to use in this visualization window. For example, if I have Chemcraft already included in my, so if I click here, the Chemcraft window will be appears here. So the only prerequisite is the software should have been installed, and if it is a license version, you should have the license. So then you can also use this freely available software like JMOL or Avogadro as well. Okay. And you can also, for example, this window is also detachable. So if you click on this detach, it will be detached, and you can place in whatever place. And then if you click on detach, it will be detached. Okay, now we'll select this AutoChemy viewer. Now, first of all, in theory method, you have an option. For example, heterofork, DFT, semi-empirical, MP method, and CCSD. So, for example, if I click on this DFT method, then it's asked whether it's this type of calculation is RKS, restricted, unrestricted, or restricted open. So, you depending upon system, you can choose. It will have an auto recommend option also. So, it will recommend, but it is just a approximation. You should always consider your system. Now, in job type, you have a variety of job types. For example, optimization frequency scan. For example, if you pick a scan here and pick atoms, so you can click on pick atoms. For example, in which scan you want to perform. For example, I have click a bond scan. I click on this oxygen and this hydrogen, and if I select this, and it will directly take its number. Then I'll start with, for example, 2.5 Armstrong to 1, and number of steps I want to perform 10. Okay, so this charge and multiplicity you can put, and the job name also. For example, by mistake, if I put any the wrong combination, the system will warn you. So it will be. Okay, now in DFT, there are various methods you can put, that is called density functional methods. So in this, there is a complete list of functions which are available in ORCA. So you can choose here. And if you click on this I button, you will see what is the which this function is best for. You can also search for here. For example, if I search MN50, I will get it. But also, there are not all, obviously, all functions which we include in this library. So you can add also. And if the function is not directly included in the Oracle library, that is being executed by libx block, you can add this libx function. Okay. Then same case for basis set. You can choose your basis set here. And then you can split your basis set also. For example, if you have some metals in it, you can directly choose this different basis set to include ECP. For example, there are different type of approximation you should consider. For this BP86, you should consider having this Grimace D3 for dispersion correction. You can choose. Then integration grid, RI approximation for speeding up calculation, and auxiliary basis set you can choose. And if you pick any wrong combination, it will warn also. Then you can pick any the parameters of this job. If you have any dependencies, you can browse and you can choose your previous file also. Now, there is an interesting feature, that is you can run ORCA. If you have installed ORCA, for that you have to go to the ORCA website, ORCA forum, and log in it, and then install the ORCA software in your system, and it will detect its path automatically, or you can give it in path also. Here you can add, and you can click on this calculation, and you can give the ORCA path. And from here, ORCA will be, for example, in my system, ORCA is already directed, and is directed, it's ORCA 6.11, and it's available. It is telling how many cores it will recommend you also. And now you can submit a local ORCA job in your system. Now, you're not bound, everyone don't want to do, certain people have workstations or high performance computers. So for that, what you can do, you can add your machines here. For this thing, you can make in the new scripts also. So to run ORCA, you have to just give the ORCA path. And if you want to parallelize the job, you can give this MPI path. You can make the script. If you give this, the AutoChemy will make a scripts as well. Or also, if you have scripts already available, so there are two options: static scripts and dynamic scripts. In static scripts, you don't want to change any parameter of the scripts. You can just add here, and you can name it, and you can just define the script. Or you can dynamically, you can copy your script, and you can select the variables. It will automatically change. So it becomes automated for you, so you don't have to every time go to your script, edit the variables. So this function, it will be useful, and you can save your machine, so automatically it will be saved for you, and it will be stored locally here. Now you have added your script thing, you have make your input. Now you can easily export, you can generate the preview, and your this input will be generated or script, or you can run it locally. Now, what you can do is, before going for any DFT method, what we recommend is taking a xTB preview. For example, if you have made anything like for a guess geometry, and you want to go for a geometry step, geometry optimization, you can always use this. Go to this xTB pre-submission. You don't have to put any other input. It will automatically take the input from input creator only, and you have to just run this XTB, get XTB preview. So it's just a pre-submission. You'll get an idea about your calculation. For example, I was taking a scan between a keto-enol tautomerism, and it gives me a very nice scan also. For example, this scan, if I see, I get a high energy point here. So I do know, basically, I can directly go for this transition state search. I don't need to perform a DFT scan here. So I can take a rough scan here. Obviously, you have to be cautious that XTB is a semi-empirical method. So it is the values are you have to be cautious. So, but it's a very nice tool for geometry optimization. And with the listed version of this, including gradient-based XTB, is really powerful. So this executable is already included in AutoChemy, so you can directly run it. And if you're using it, don't forget to cite the its creator, that is Professor Greeny's group. Okay, now you have pre-submitted it, and now you are good to go. Now, obviously, you have, for various projects, you will use different functions, different method, and everything will be different. So for that, we have created a project window in which what you can do, you can save this whole panel settings, and you can save this current, and you can make the project or sub projects under sub projects, and you can save. So all settings will be saved. For example, if I go to this tab, and if I go to my this tab, and I will click here, my all settings will be changed, and according to whatever I have saved. So it will be very useful for doing multiple projects. That is the our vision, that it saves your time and helps to organize. So that's it for the input creator. Next, we'll talk about the potential energy surfaces. Thank you.